should be taken into account. Because in the case of reproducible goods, you can have the product in the future even if you are using it today. So, but in the case of exhaustible resources, that is not possible. So that's why this condition of optimal use of the resource, which is normally given in the form of P is equal to marginal cost, price is equivalent to marginal cost, that is modified, and that modification is something like price being equivalent to marginal cost plus user cost. In essence, we can say that this is a price being equivalent to augmented marginal cost. So which is shown here, P is equal to MC is equal to number 1. But whereas in case of exhaustible resources, the condition is modified as P is equal to MC plus UC. Probably it's not so visible because the scan was not very good. And this is one of the problems that we are facing in the case of online classes. And that can also be shown with the help of a diagram. It's a kind of demand curve, you can say so. So on the x-axis you have the quantity, and on the y-axis you have the price. So the demand curve is given as a downward sloping curve, where P is expressed as a function of quantity, or otherwise also we can express it Y as a function of price. Of course, the correct option will be P is equal to Py. Now here, what we are using, assuming is that the marginal cost of providing the resource remains. Yes.
So your screen is not visible.
Screen is not visible.
Yes, sir.
The quality is not very good. Let me tell you. Quality of the scan is not very good. But of course,
We are not
I believe you are not seeing anything. Just
yes.
wait a minute. Let me try once more. Can you hear me or not?
Yes, sir, we can hear you.
Okay. Just check once more. Can you see now? Is it visible or no?
Yes, sir, it's visible, but we are seeing the Teams window.
Teams window only. Just a minute. Let me check another file whether that is okay or not. Can you see the PDF?
Yes, sir, we can see.
Yes, sir.
This is visible, right?
Yes, sir, yes.
Okay, I was talking about this equation. P is equal to MC plus UC. So we discussed about this one. Actually, this is a modified one. This P is equal to MC plus UC. No? So this one which gives us the optimal amount of resource which is to be which can be utilized. So where UC is the kind of user cost, or in essence you can say opportunity cost. So with the help of a diagram over here, you know, I tried to show you this diagram yesterday. So here the quantity is on the x-axis, price is in the y-axis, and we have the demand function which is given as a function of income. Price is a function of income. So relationship is inverse relationship, and so that basically shows the demand for the product, how much demand is there for the product at different prices of the product. Okay, so if it is a resource, so the price of the resource will determine how much of the output will be, how much of the amount will be demanded by the people out there. Now here, if we look at, we find that there is a marginal cost curve, MC curve. There is an MC curve. So basically that shows the marginal cost of extraction of the resource, or maybe providing the resource. Now, if we take only MC into account, then marginal cost and demand curve intersects at a point, and which ultimately gives result to an output which is given as Y double star. Now, this Y double star is the amount which needs to be produced or provided or supplied when the marginal cost is taken as MC and the demand function is given something like this. So this is the true picture in the case of reproducible ordinary goods and services. But in the case of exhaustible resources, so what happens? We need to take into account the fact that once the resource is utilized, the resource will no longer be available for use in the future. So that means there is a trade-off in the use. So there is an opportunity cost, and that opportunity cost is considered to be the marginal cost. Now, if that marginal cost is taken into account, for example, we assume that the marginal opportunity cost is equivalent to AB, right? AB. So you have seen that AB. The user cost, and corresponding to that user cost, again you see, so this is a point which is on the demand curve. Now from that demand curve, if we draw a line so parallel to y-axis, so that will meet the x-axis at y star. Basically that means, you see, this marginal cost person is by star person, the AB person will be the user cost, or maybe you can say opportunity cost. So in that sense, what we can find is that so this particular thing, this Y star, when we are talking about that much of output to be produced or maybe provided, so that is taking into account not only the marginal cost, because the marginal cost portion is by star. This amount is taking into account that it's amount which is produced here or maybe provided here is reflecting this marginal cost, no doubt, but along with that, it is also taking into account the opportunity cost or user cost. In essence, what we can say is that this value is nothing but MC plus UC. So the price probably will be equivalent to this much. Okay, this much might be the price. So P will be equivalent to this MC plus UC. So that should be the condition for kind of optimal extraction of exhaustible resources. The same thing can be interpreted a little bit differently. So by taking into account two different time periods, because we are talking about the present time period as well as any future period. So when you take into account any future period, so we might consider one time period in the future. The present time period might be another time period. So we can consider this problem to be a problem associated with two different time periods. So that is how we'd like to see this problem. For that, again, I have to go to the previous file. Let me see whether it is possible or not. Is it visible to you? The file, handwritten one?
Yes,
Can you
sir.
see that one?
Yes, sir, visible.
Yeah. Yeah. So here, what we are trying to do is that we'll be considering two different time periods. So suppose a period 0 and period 1. And so if there is a resource owner, for example, of a coal mine or maybe a kind of petroleum oil field, so that resource owner might extract a resource and sell the product in today's present period, or maybe he can retain it in the ground till period 1. There are two options available to him. Either he can extract it today and sells it to the consumers today itself, or maybe he can retain it in the ground and maybe he can think of extracting it in the. So if he extracts the resource today, so he can expect a price, and that price is given as P naught because it is a period 0. And the price he can expect in the future period, maybe in the next period, might be equivalent to P1. There is always a cost of extraction of the resource, and the cost per unit of extracting the resource and delivering it to the buyer is considered to be C, which is considered to be not to be varied across the two time periods. So in that case, the additional cost for providing one extra unit of the resource remains the same. So that basically means that the marginal cost C is nothing but the marginal cost, and this marginal cost remains constant. Okay. Now, as we know, so this is an exhaustible resource. The stock is fixed. So any unit which is extracted and sold in present time period, suppose period 0, So that will reduce the amount that will be available for selling in the future period one. Okay, that's a kind of rivalry in consumption that we talked about. So so that is the issue. So there is a trade-off between. So if we use it today, so it will not be available for tomorrow. If we wait for tomorrow, so it will not be used today. It's something like that. So if a unit is utilized today or extracted today in period 0, so the total resource stock will be reduced by that amount for period 1. Okay, so there is an opportunity. Cost involved, user cost involved out there. Now, let's assume that he sells the unit in period 0. So if he sells the product in period 0, he will get a price equivalent to P0, and there is a cost involved in the process. So net revenue that he will be getting is equivalent to P0 minus C. But at the same time, the product could have been utilized in the future, period 1. So if he uses the product today, the opportunity that he will be foregoing in the form of revenue might be equivalent to P0 minus. Here C is, as we talked about, is the marginal cost, which remains constant in the 2 periods. So he forgoes an amount of P1 minus C as the revenue in period 1. Okay. So so we can make use of a concept which is known as the present value of certain things, present value of revenues, you can say, or cost, you can say, whatever it may be, because we are talking about a future value of the resource. We are saying that future value of the resource is P1, and the amount that will be foregoing today by using the resource today is P1 minus C. Now, if we have to make an estimate how much we are actually losing by using the resource today, so normally we discount it, or maybe we can find out the present value of that P1 minus C in the present period. That present value can be expressed as P1 minus C divided by 1 plus R. Here, P1 minus C is the net revenue, and 1 plus R, this R is nothing but the discount rate. It is known as discount rate, but basically this is the rate of interest which is prevailing in the economy. For example, if we know that the rate of interest which can be earned by investing a particular amount in a bank is suppose 5%, then this R might be equivalent to 5%. So in this sense, we can discount the value of the future value of a particular variable at the rate of this discount rate, which is nothing but the rate of interest in the bank or maybe in the financial sector. So we can find out, we can so in the next section, what I'm trying to do is to show you how this present value can be estimated. So taking a different example. So this is the thing. So how we are trying to estimate. So we are saying that this P0 minus C by 1 plus R is the present value of the revenue, net revenue, that will be net revenue, which will be foregone by using the resource today. So for estimating the present value, you can go for this type of a formula. So how can you deduce this formula? So let's take an example. So just assume that an amount equivalent to a naught is invested for a period of 1 year. So after 1 year, normally what will happen if you invest a naught amount of suppose income today, then this a naught should have some kind of earnings in the year. So at the end of the first year, this a naught value should be increased by some proportion or some rate. That rate will be nothing but the rate of interest which can be earned, right? So if we invest a naught amount today in the bank, so there will be an interest rate. If the interest rate is supposed to 5% or 10%, in the future we'll be getting a naught plus a naught into that 5% or 10%, because you need to earn some interest on that, right? Since you are investing. So that is the amount we'll be expecting. So this amount which will be received, suppose is equivalent to A1. So that should include the initial investment A0 plus some earnings on it, which is equal to the current rate of interest. So let us assume that the current rate of interest is equivalent to R. So in that case, the amount which I'll be expecting to earn at the end of the year, which is equivalent to A1, so that will be just equivalent to A0 plus R into A0. So when you actually further kind of analysis or maybe kind of simplified, you will get this A naught. So basically it means A naught invested initially increases at the rate of 1 plus R to become A1 at the end of the first year, right? So if we discount, see, if we discount the earnings after 1 year at this rate, basically when you talk about present value concept, no? So present value concept is nothing but finding out the present value of this earnings by discounting the earnings at this rate. Okay. When you say present value of suppose A1, since we are talking about a future income, so normally we talk about present values of the future incomes or future values, and out the present value of the earnings in the first year, maybe in the second year, whatever that may be. So till the period the earnings are coming in. So we can have present value of A1, which can be given as A1, which is discounted at the rate of R. So A1 divided by 1 plus R will give us the present value of the earnings, which will be earned after 1 year. Okay. So similarly, we can find out the present value of future earnings by discounting future earnings at a given rate of discount. So similarly, we can find out present value of the earnings after second year, so which can be given as A2. A2 will be equivalent to A2 by 1 plus R to the power 2. Of course, you can find out how it can be something like this. Always you can do that. So if there are a series of incomes which are forthcoming from an investment over a period of time. So and the life is suppose n period. So in that case, the total present value of the earnings over a period of time of that investment can be shown as the sum total of this discounted kind of investment value over a period of time. In the first period, for the earnings in the first period, the present value will be A1 by 1 plus R. For the earnings at the end of the second period, the present value can be equivalent to A2 by 1 plus R to the power 2. For the earnings after third year, the present value will be equivalent to A3 by 1 plus R to the power 3. And that way it goes. And for the nth period, the present value will be given by n by 1 plus R to the power n. Now, if we have to find out the total present value of the investment over the life period of kind of, in essence, you can say over the period that happens actually. If you invest something today, over a period of time, every year, probably after some time, you will be getting some streams of income. It might be in life insurance corporation or maybe any other investment funds. You can think of doing that. So this type of things are there. So total present value for the investment might be given as the sum total of this stream of income discounted at the rate of specific interest rate. So 80 by 1 plus R to the power t, when you sum it together for the period from 1 to nth time period, you will get the present value, total present value of the total income of the investment which are realized over a period of time, right? I hope it's clear to you regarding present value, estimation of the present value. Now, if you define the present value or maybe estimate present value like this, then you can rewrite the equation or maybe rewrite or reinterpret the things that we have talked about already regarding the exhaustible resources. Now, what we can do here is that we can write an equation about the return for the seller. So who will be selling a unit today. So for him, the net return will be something like this: P naught minus C, where P naught is the price, or maybe you can say revenue, whatever that may be. P naught minus C is nothing but the net revenue which the seller will be getting by selling or extracting and selling the product today. But at the same time, he will be foregoing some amount, which is actually this is nothing but the amount which he would have got in the second period, period 1, for example. So that amount is equivalent to P1 minus C. But since we need to find out the present value, because since we are comparing it today, there is a kind of price inflation kind of a thing. So that needs to be taken into account. So that's why the current value or present value of the future income, the next period, that is to be estimated, that is done by discounting it at the rate of R, where R is considered to be the rate of interest. So So we are foregoing this value. So that's why the net income will be given as P naught minus C minus 1 minus C divided by 1 plus R. So when we rearrange these things, so we can find out another equation. I'll go to that. Now here, this P1 minus C by 1 plus R. So that is considered to be the opportunity cost of the decision to sell the unit of the resource today. Because so this is the opportunity which will be lost in taking the decision of selling the unit of the resource today. So that's why it is also representing the user cost of the decision to make use of the resource. So obviously, when the resource owner has to take a decision whether to extract the resource today or to retain it in the ground, so he will have to compare these two values, whether P naught minus C value is equivalent to P1 minus C by 1 plus R, or it is greater than or less than. So based on that, he will try to take a decision whether he will go for extraction of the resource or whether he will leave the resource in the ground. For example, if the P naught minus C value, that means the value, current value of the price or maybe returns that he receives by extracting the resource today is greater than the opportunity cost that he will be foregoing in the form of the revenues that he will be foregoing in the future. So that basically means that he will be better off by selling his resources today. Okay, so he will take a decision of selling the resources today because the opportunity cost will be much lower. But if it so happens that P naught minus C value is much lesser than P1 minus C by 1 plus R, obviously he will not try to sell off the resource today. He will be better off by leaving the resource in the ground. Okay, so obviously in both these inequality things, okay, so he may not be kind of in equilibrium position. So obviously there will be a condition. So for optimum amount of current extraction, and that is given as the situation when these two values are just equivalent. So the resources or net revenues extracted today or maybe availed today is just equivalent to the net revenues to be received in the future, the value of which is found out by discounting the future value. So P naught minus C should be just equivalent to P1 minus C extracted discounted at the rate of R, so divided by 1 plus R. So this is equation number 4. On transpose or rearranging, you can find out that P naught is equivalent to C plus P1 minus C by 1 plus R, which is equation number 5. So this equation number 5, in essence, on the left hand side we find P naught. P naught is nothing but the current price of the resource when it is extracted optimally. Now this should be equivalent to C plus P1 minus C by 1 plus R. What is that? C is nothing but, we assume that C is nothing but constant or marginal cost, right? And this P1 minus C by 1 plus R, we say that this is the opportunity cost, or in essence, this is the user cost. So what we have found is that price is just equivalent to a marginal cost plus user cost. So that is what already we have obtained. Okay, so when we say that the marginal cost should also take into account user cost, so while talking about this optimal condition for resource extraction, so the same thing we could find in a different form, where we have found that price is just equivalent to augmented marginal cost, which includes both the marginal cost of extraction and opportunity cost or maybe user cost, right? Just give me a minute. Well, so this is the case of exhaustible resources, but if it is a reproducible resource, in the case of reproducible resource, that opportunity cost will no longer be there. So in that case, because you can reproduce it with the help of resources. Resources are available. So that's why this optimum output will be provided when the condition of price being equivalent to marginal cost is satisfied, right? So this P naught is equivalent to C. So that condition marginal cost is equivalent to the price of the product. So that is the optimal condition for provisioning of the product out there. Now, so on rearrangement of equation number 5, we find something like this. So we can find P1 minus C divided by 1 plus R to be equivalent to P naught minus C. So in that case, P1 minus C can be considered to be P naught minus C multiplied by 1 plus R. So that can be equation number 6. And this equation number 6 is considered as the second condition of optimal depletion. In a sense, this is also known as the fundamental equation of exhaustible resources. A fundamental equation of exhaustible resource extraction. This was given by actually Harold Hotelling in 1931, and so this is another fundamental equation. Mostly same actually, both the things are same, but in a little bit different form. So what this equation says is something like this. So this equation tells us that along the optimal extraction path, where the resource owner is indifferent as to the options of extracting or leaving the resource in the ground, the price of the resource net of marginal extraction cost, because we are talking about P1 minus C, for example. So this P1 minus C is the price in the next period, second period. So this price or net revenue, in essence, price of the resources net of marginal extraction cost. That is the user cost has to write the rate. So which is given a discount rate is R. So P naught minus C multiplied 1 plus R. That gives that, in essence, P naught minus C plus R into P naught minus C. So that kind of net price increase at that rate, right? Now, if the marginal cost of extraction is very small relative to the price of the resource, then what we can find is that the C will be 0. The C that we are talking about, that will be 0. In that case, we'll be having an equation like this: P1 is equal to P plus R. Okay, P1 is equal to P naught into 1 plus R, or in essence, you can say P1 by P naught is equal to 1 plus R. So if that is the thing, so when we are considering that the marginal cost of extraction is very low relative to the price of the resource, so in that case, you can rewrite this equation again as P1 equivalent to P naught not given here in this equation. So that basically means that along the optimal path, resource prices grow at the discount rate, because P1 is equal to P naught into 1 plus R. So price, actually P naught is growing at the rate of the discount rate. The higher the discount rate, the faster the rise of resource price along the optimum path. Okay, a higher discount rate will reduce the user cost of the resource and causes mine owners to deplete their resource at a faster rate. Okay, so that is the situation when we are saying that the extraction cost is very small, and we are considering this C to be equivalent to 0. But in normal situation, extraction cost can never be 0. So they will be having some positive values. So whenever they will be positive, a price increase equal to the interest rate will cause the net price to rise by more than the interest rate. So that is another issue actually. So in a sense, this concept of opportunity cost will play a very important role out here, and this value of R will also be very important out here. Okay, so these are so these two will be actually telling us, okay, how much of the, or maybe when the resource will be extracted, whether it is in the present period or in the future period. For exhaustible resources, although we can say that technically and the marginal cost might be very small, but it may not be very small. If it is not very small, of course, the condition that the price will be growing at the rate of the discount rate, that may not be the correct thing. So we have to think about this net price only, not the absolute price of the resources. Is that okay with you? There are certain examples given out here. You can have a look into that. Of course, one article has been shared with you. Just try to have a look at that article. So that will give you some more explanation on this issue, right? Of course, along with these, in the case of exhaustible resources, these things can also be explained actually. It can be established with the help of mathematical equation. We'll try to do that as well, if time permits. But there are certain other things which should also be taken into account while talking about exhaustible resources. Now, one thing is, so when should we think about a substitute of exhaustible resources? Okay. The thing is that so when you talk about substitute of an exhaustible resource, this is also known as backstop. Now, this backstop basically in the case of exhaustible resources, since the nature is that the resources exhausted, or maybe resources being exhausted because of constant use of the resource, then people look for alternative sources of alternative resources. For example, when you talk about these fossil fuels, so we know about the depletion of the fossil fuels. Petroleum product is getting degraded. Similarly, coal and other fossil fuels are going to be exhausted. So under this situation, so what is thought of as an alternative source of energy is a kind of renewable sources. So maybe in the form of water, maybe in the form of solar energy, and all those things people are looking into. Now, what are the conditions under which there will be transition from use of the exhaustible resources to a kind of renewable resources? That is one issue. Okay, there are certain kind of models which explain this. But basically, so what happens with increased scarcity of the exhaustible resources? The price or maybe the cost involved in the process will increase or go up, because you see, you have to extract the resource. Okay, this extraction cost might also go up, because initially what happens, the resources which are easily available, so these are extracted. After a point of time, when scarcity is increasing, then you have to go deep, and ultimately you have to extract the resources from deep aquifer and so many things. So ultimately the cost of extraction goes up. Also, along with that, kind of opportunity cost or maybe user cost also goes up. So both these things make the price of the product very high. So over a period of time, okay, so it so happens that the people will be looking for alternatives, and at a point when they find that the price of the exhaustible resource is just equivalent to the price of the renewable resource, then the people will be switching over from the exhaustible resources to the renewable resources. That is the price at which switching over from the non-renewable sources to the renewable resources takes place. That is known as the backstop price. Okay, so that backstop price is very important, because we have to take a call. So when we have to switch over from one resource to the other resource. So this is also known as the choke price. Choke price basically tells us, or maybe talks about, the upper limit on the augmented marginal cost. So this is basically what happens. We assume that this augmented marginal cost for the exhaustible resource should not exceed the marginal cost of the substitute, because if the substitute is available at a price, okay, at a lower price or maybe lower cost, obviously people will not go for use of the exhaustible resource. So that's why theoretically this augmented marginal cost for the exhaustible resource cannot exceed the marginal cost of the substitute. The society could always opt for the use of a renewable resource instead, whenever it appears cheaper to do so. Okay, so although the maximum willingness to pay sets the upper limit on the augmented marginal cost, and for that matter on the price, when no substitute is available. The marginal cost of extraction of the substitute sets the upper limit when a substitute resource is available. Okay, so that is why marginal cost, maybe marginal cost of the kind of substitute will be determining the backstop price or maybe the choke price at which the society will decide to switch over to the substitute renewable resources from the exhaustible resources. Another thing is that with technological progress, many of the resources can be made available for the society at large. We talked about this potential reserve, right? We talk about this resource endowment while talking about this kind of different terminologies that we use in the case of resource. Now, so although we say that current reserves may not be very large, but the potential reserves can be large because if the people are willing to pay higher price, okay, higher amount of the resource can be made available. Now, obviously, with technological improvement, okay, there is possibilities of going deeper for exploration. Okay, normally, in principle, extraction cost may go or maybe increase over time as the lower cost reserves are depleted and higher cost reserves remain to be exploited. The search for new resources will be based on the cost because that will involve some cost. So when more easily accessible resources are exhausted, okay, so people have to move into less accessible areas like the bottom of the sea or high slopes of mountain. So in that case, what will happen? Exploration cost will go up. So exploration cost or marginal cost of exploration, you can say so. That is the marginal cost of finding an additional unit of the resource that is expected to go high. So there are two things. One is the extraction thing, and the other one is the exploration thing. The marginal cost of exploration might also go up along with marginal cost of extraction. So exploration might have to be carried out by the people, and some of the exploration might be successful, some may not be successful. If the exploration is successful, okay, kind of the reserves of the resources can be enhanced or augmented. If not, then the resources reserve cannot be expanded. So, but one thing is for sure, in the case of exhaustible resources, ultimately, because we know that resource is scarce, we cannot continue making use of the resources for an indefinite period of time. So there has been increasing awareness amongst the people that we have to think about kind of alternative sources of energy, particularly. Very much important from the point of view of overall sustainability. A number of issues are there when you go for use of these fossil fuels. One thing is that so the resource gets exhausted soon, and secondly, there might be some negative impact on the society at large also because of environmental pollution happens out there. Of course, pollution, as I pointed out, will be happening everywhere at any point of time whenever there are economic activities. Now, the fact is that so we try to find out a situation where the pollution or environmental degradation gets reduced. So that is what we try to do. And in fact, for that, there has always been search for better and alternative resources, which can help in improving the quality of the environment, and at the same time can substitute the exhaustible resources that we are making use of today for our survival or for getting benefits out of different resources available. So that is why in recent years, if you look into, there has been a lot of kind of research being carried out, and a lot of new products are being made available. So energy from biofuels and so many other things are coming in. Of course, commercial viability of many of these things hasn't been properly looked into. So once the cost goes down, probably these things will be used more and more. So because so although we talk about use of solar energy or hydroelectricity and so many other things, so there are certain negative externalities associated with them. maybe some negative externalities might be there, and also might be the cost of production might also be an issue. So in case of solar energy, normally it is considered to be relatively better energy source. But the fact is that the panel cost is even today is relatively high. So governments are trying to provide these facilities to the people by announcing some kind of subsidies. In case of India also, we see a lot of subsidies are being provided for these non-conventional renewable energy sources. But in the absence of that, how sustainable these energy sources are, that is a matter of question. So if better technologies are made available by which the cost of extraction or cost of generation of solar energy gets reduced, then obviously it will be accessible to everybody. And in that case, probably that will help us in overcoming many of the problems of using fossil fuels for getting our energy resources. So research should continue. We need to find out ways of reducing the cost of extraction or maybe a kind of generation of energy from this type of non-conventional energy sources, because we know it very well that this from the point of view of overall environmental sustainability and from the point of view of overall sustaining the resources, probably the current consumption or current consumption pattern or current usage pattern may not be kind of sustained over a period of time. Fossil fuels will anyhow be depleted within a few years' time, probably. So in that case, we have to find out alternative ways. So this technical solution to these issues, they have to be found out so that this non-conventional energy sources can be used more and more for the benefits of the society at large. So there are so many other issues involved out there. So probably we'll try to have some kind of a mathematical explanation to these issues. So how to make optimal use or extraction of these resources, particularly these exhaustible resources. We'll try to have a look at that. And after that, we'll try to have a look at the optimal allocation of renewable resources by taking certain examples like fishery, like forestry, or maybe water reserves. So those things will take into account one by one. If you have any question so far, please raise your question.